The video demonstrates the simulation of the aircraft's 3D motion along waypoints marked in red which are generated randomly. The motion calculations, including the corresponding graphical display in the form of animation, are performed in real time. This means that the rate of calculations is such that at the current time moment, it is possible to perform several options for calculating one's possible movement and choose the optimal one from them. Thus, the aircraft's continuous response to a change in flight direction or the absence of such changes is ensured. The trajectory of the predicted motion in the animation is marked with bright dots in front of the aircraft. We see that the aircraft's motion is calculated for some time into the future. In this case, it is 4 to 5 seconds at the calculation's frequency of is about 300 hertz and with a time integration step of 1/100th of a second. A few words about the mathematical model used, which contains 6 degree of freedom equations of motion and takes into account mass, moments of inertia, aerodynamic coefficients. The equations of motion are also supplemented by control and stabilization algorithms. Control is carried out by forces that simulate the action of ailerons, pitch and course rudders, and engine. Stabilization is provided by forces that are determined by physical criteria. This aircraft has a mass of 5 kilograms. The physical parameters of its motion are displayed on the left. In particular, this is the speed in meters per second, the power on the propeller in watts, the thrust in newtons, the energy in kilojoules. The forces and moments acting on the aircraft are also displayed. This is the main vector of aerodynamic forces applied to the center of gravity and the main moment shown from the left wing. We also see the vectors of the roll, pitch, yaw forces, and the aerodynamic moment of the wing shown from the right wing. The lift force is not shown, but it can be judged by the main vector. The thrust vectors are also shown.